5-step approach in deciphering a rhythm strip. What we're looking at is actually the conduction system of the heart. We begin with the sinoatrial node, the SA node, and that's located under the posterior portion of the right atrial wall of the heart, but it is the primary pacemaker. It's 60 to 100 beats per minute would be their firing rate of the SA node. So that would be how the SA node sets its pace. The SA node discharges impulses at a rate of 60 to 100, like I said, but if a patient is actually bradycardia, it is said that they have a heart rate less than 60 beats per minute. If they're tachycardic, they have a heart rate greater than 100 beats per minute. Then there's the internodal pathways. The internodal pathways receive the electrical impulse from the SA node as it exits. Then it transmits that pulse from the SA node to the AV node. Botman's bundle, that's a group of those interatrial fibers contained in that left atrial. It's a subdivision of those anterior internodal tracts. So it conducts the electrical activity from the SA node to the left atrial. Now, the AV node is located on the floor of the right atrium above the tricuspid valve. Only pathway of that electrical impulses is to the ventricles. It's very much a backup pacemaker. The AV is where the SA nodes joins the bundle of His. If the SA node fails to fire or slows before the normal rate, the AV junctional tissues initiate an electrical activity. So in that way, it's considered the secondary pacemaker. The bundle of His is the conductional pathway that leads out of the AV node and lies on top of that intraventricular septum. Is referred to as the common bundle. Its firing rate is 40 to 60 beats per minute. Purkinje fibers, it goes on around and wraps around. It spreads throughout the ventricles. It carries impulses directly to the ventricle muscle cells, and that intrinsic firing rate is 20 to 40 beats per minute. Now, if all else fails and we're relying on the Purkinjes to fire at 20 to 40, you know that the patient will be very symptomatic. They will be syncopal. They may have a change in level of consciousness, most definitely have a very much of a decreased cardiac output. So, therefore, you can just know that there will be a decreased perfusion to the vital organs and to the heart. Measuring that electrical activity we do with an EKG. These are electrodes that are attached to the skin, and we've all seen those. And what it's measuring is the electrical activity in the heart. There are the single lead monitors that we hook them up to. They're pretty simple. They can either be 3 or 5 leads. We'll go over the 3 lead in a minute. It's mostly bedside monitoring. You see that in a telemetry. These single lead monitors. It's not meant to be a diagnostic tool. It's meant for a monitoring tool to look at for basic rhythms. Nurses should know the most ominous rhythms, basic dysrhythmias. They should be able to pick up on those and report that out. Now, they're not diagnosing from this at all, but they do need to know enough to monitor that telemetry and or that monitor and pick up on any dysrhythmias. Now, the 12-lead EKG is a diagnostic tool. It picks up on ischemias. It's used to, physicians will be able to look at that to diagnose dysrhythmias and conditions of the heart. I'm sure there's a lot of savvy nurses out there, especially ICU nurses. It's been there a while that can also diagnose, to look at a 12-lead EKG, but we are not there to diagnose at all, only to monitor. So the placements on a 3-lead would be your white is on your right shoulder, your black is on your left shoulder, the red is in the left middle area at the lowest point of the rib, or you can see them on 5 leads on the right leg, on the left leg. Many people say white on right, and then smoke because it's black, like black smoke, over fire, which this lead would be red, so that would be white, black, and red. Now, EKG monitoring is very standardized. It runs at 25 millimeters a second. It has to do that. The colors will vary. You may get a pink slip, a green slip. It does not matter. It just depends on the company that makes it. It's marked in 3-second intervals. The horizontal axis represents time, and the vertical axis represents electrical voltage. And here is a picture of that. Now, for us, we're going to be looking mostly at time. We're not going to be, when we're reading these little 6-second strips for our test and all, we're not going to be looking at as much at amplitude or voltage, only duration, and we'll go over that. Time is measured in blocks. One whole block is 0.20. So five of these 0.20s would be considered a second. And then within each one of these big blocks is small little blocks, and that is 0.04 seconds, and that it takes 5 of those to make up one big block there. So if you have a 6-second strip, then you should have 30 small blocks, these little bitty blocks. Okay, so but here's an EKG monitoring paper. The easy way to calculate rate is to look at a strip and count the QRS, and the R is at the top, so that's what I count. 1, 2, 3, 4, 5, 6, 7, 8. That would be 80 heart. That would be the heart rate. You can see where this is 1 second and this is 3 seconds. Now this is a 6-second strip, and so these 2-3 seconds would make a full 6-second strip. And these are exactly the strips that you will see on the test. It will be a 6-second strip, and that's how you will see that. This is just a depiction of the electrical cycle. We know that the P wave represents atrial depolarization, and we look for the roundness of the P wave. Then we have the PR interval from here to here until we get to the Q wave, the RS, and then the T wave segment, the T wave here, and then you will also find that there's sometimes a U wave. Now, you will not pick a U wave up on a 6-second strip, so we're not even going to be concerned with the U wave. So again, the P wave is the first wave produced by the SA node. It's smooth, it should be round, upward deflection. This right here, just to mention, this is your baseline. When we say upward deflection, it would be anything that goes up from your baseline is considered a positive deflection. Anything that goes down from the baseline is considered a negative deflection. So if you ever hear those words, you'll know that it's actually something that goes up and down from the baseline of the cardiac strip. The PR interval is the measure from the beginning of the P wave, okay, to the beginning of the QRS complex. It represents the atrial and AV node depolarization. The normal duration for that is 0.12 to 0.20. QRS complex, the QRS, of course, is the first downward deflection, although not all the time you will see a downward deflection in the QRS, but they are there most of the time. R wave is the first upward deflection, and then S wave is the downward deflection. Okay, the QRS represents the conduction, consists of conduction of the impulse to the ventricle muscle. So it's ventricular depolarization. Here's your QRS. That should be the QRS duration, or say this right here, QRS, how wide that is. For it to be normal, it should be 0.04, which is one of those very small blocks, to 0.10 seconds. And then, again, here's the QRS. Segment here. We just talked about that. So the P wave and the QRS complex and the T wave is what we're looking at. And it's depolarization, repolarization with the T wave. Okay. So general rules is to first and foremost look at your patient. You never treat the strips, the rhythm strip. You only treat your patient. Rhythm strip is like having lab values. You're evaluating it as just a tool to help evaluate your patient. But you would never go to a lab slip and look at it and go, okay, I'm going to look at that and start calling the doctor because before you even see your patient, because, you know, your patient may look a whole different thing from that lab value. Same thing with this. If you have a strip and you look at it and to you it looks awful and you don't look at your patient, then it's also a poor evaluation, or you should not ever treat that. But with the general rules, you will be applying a 5-step systematic approach to each strip. The 5-step approach is in order. First, you're going to do heart rate, then heart rhythm, P wave, then PR interval, and then QRS complex. So with the heart rate, number of electrical pulses are represented by the PQRST complex is conducted through the myocardium in 60 seconds, or 1 minute. Now for the atrial rate, you would want to count the number of P waves, if that's what you wanted to find out, just the atrial rate. Or the ventricular rate, you would count the number of QRS complexes noted. Now, for the 6-second method, you can strip is usually marked like we saw before in 3 to 6 seconds tick marks on the bottom of the page of the graph paper, and you count the number of QRS complexes occurring within that 6-second interval, and then multiply by a number by 10. Now then, this is a sample of a 6-second method, and we're going to count the QRS complexes. So that's 1, 2, 3, 4, 5, 6, 7, 8, and this again is 6, so that's 80. 8 times 10 is 80, is how we would count that rate. Heart rate determination, again, we can count the R to R intervals. Most accurate if the heart rate is regular, an estimation of the heart rate, look at the QRS complex that falls on a heavy line on the strip and count the number of large boxes between the R wave and the next R wave and divide this number into 300. Now, we're not going to, I don't use this method, but that is just another method. I use the QRS, I count each QRS complex. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you would multiply that by 10, so that's 100 heart rate. But doing the R to R method, I was just showing that, but that's not what I would really consider I would do. I want to keep that simple. Then we're going to look at the heart rhythm. The heart rhythm is a sequential beating of the heart as a result of the generation of electrical impulses, of course. They can be classified as regular pattern or irregular pattern. So you're looking at the P waves on how they're really marching out. Are they marching out really regular, or are they short here and long there and they're not regular at all? That would be an irregular pattern. You don't want to try to eyeball. You want to use either calipers or paper or pencil or a counting method. Calipers are good. We have them in the lab. The paper and pencil, we'll probably do it in testing. I'll show you a picture of that. Counting method would be very tedious to count each little block without having something to measure it off. This is how you would measure calipers. So you're looking for rhythm, whether it's regular or irregular. So you're going to keep measuring those out on that 6-second strip and see if there's a difference in that, a significant difference between these QRSs. But you can do the same thing by just measuring, just taking it and taking a piece of paper and making tick marks, and you can see there too if there's a regular or irregular pattern. A regular rhythm is the measures between the P to the P wave or the R to the R wave. So you're going to go from the P to the P wave or the R to the R wave. If the intervals vary by less than 0.06 seconds or 1.5 small boxes, we consider the rhythm to be regular. For an irregular, the intervals of the P to P or R to R waves are variable by greater than 0.06 seconds, and then it's considered to be irregular. But then you can go on to further define irregular. There's regularly irregular, that actually is irregular rhythms that occur in a pattern. So you might have several you might have several irregular rhythms, but it's regularly done throughout your strip. So that's what that means, that they're irregular, but they're much less, they're more or less the irregularity is that that pattern tends to go over and over. That's the best way I know how to put that. And the occasionally irregular intervals of 1 or 2 R to R's are uneven. That's when you have an occasional. And the irregularly irregular is when the R to R intervals exhibit no similarity at all. So practice strip for rate and rhythm, you would need to measure this. out. So I'm going to measure this out, and you can too, with a piece of paper. And you can just put a tick mark at your R's. So this is a regular rhythm. And then right here, now you can do your P waves or your QRS again. Okay, so what would this be? It would be irregular, probably irregularly irregular. The P wave, step 3, the P waves, are P waves present? These are the questions you have to ask yourself. Are the P waves present? Is the P wave upright? Is there a P wave for each QRS complex? Is there a QRS complex for every P wave? 5 questions to ask yourself are P waves present? Are P waves occurring regularly? Is there one P wave present for each QRS complex present, or is there a QRS for each P wave present? Are the P waves smooth, rounded, and upright in appearance, or are they inverted? Do all P waves look similar? So that's a lot of questions you need to ask for your P waves. For this, okay, you would need to ask those questions. I'm going to give you a second to look at that. So, is there a P wave, are P waves present? Yes, they are. There's P waves present. Are the P waves upright? Yes, they are. Is there a P wave for each QRS complex? So for each QRS complex, there's one there, 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 and one there. So, yes, there is. So you want to measure the time interval of the onset of the atrial contraction to the onset of the ventricle contraction. So it's measured from the onset of the P wave to the onset of the QRS complex. Normal is 0.12 to 0.20 or 3 to 5 small squares. 3 questions to ask are PR intervals greater than 0.20 seconds? Are PR intervals less than 0.12 seconds? And are the PR intervals constant across the EKG strip? So here's PR intervals. So there's one there. So, can you see that the PR intervals measures within normal limits? Step 5, the QRS complex, represents the depolarization or contraction of the ventricles. The Q wave is your first negative or downward deflection. Sometimes you may not see that downward deflection. R wave is the first upward, and S wave is the sharp negative. Are the QRS complexes similar in appearance across the EK strip? Normal QRS duration is 0.04 to 0.10 seconds. Are QRS greater than 0.12 seconds wide? So, let's look at this one. So, are the QRSs similar in appearance across the EKG strip? Yes, they are. Normal QRS duration is 0.04 to 0.10 seconds. Okay, so measure those out, and they're within normal limits. The ST segment begins with the end of the QRS complex, and it ends with the onset of the T wave. Also there's something called the J point. It's the point at which the QRS complex meets the ST segment. But how you decipher the ST segment is you begin with the end of the QRS complex and the onset of the T wave, consistent with that line. So if the ST segment is elevated or depressed, it could mean a myocardial infarction or injury, ischemia could be there. So the ST deviations here, this would be an ST elevation because that's QRS, and here's how it's elevated here. Instead of going all the way down, it's way up here. Then there's the ST depression, which goes down there further than the baseline. Here's your baseline. And then there's a digoxin dip. This just shows a digoxin dip there. The T wave is produced by the ventricular repolarization relaxation, commonly seen as the first upward or positive deflection following the QRS complex. Usually the U wave is not usually visible, and you can read that, but we're not going to be concerned about the U wave. Artifact, we can certainly have artifact on a EKG. There's 4 causes: patient movement, loose or defective electrodes, improper grounding, faulty EKG apparatus. And this is what that would look like. Just one strip. There's different artifacts you might see other than that. And this is a normal sinus rhythm. And how do we know? Because the rate, we count the rate: 1, 2, 3, 4, 5, 6, 7, 8. Now these 2 tick marks here means that that's the 6 seconds. This is from this tick mark to this little one is 3. From this one to this one is 3. So we counted 1, 2, 3, 4, 5, 6, 7, 8 is 80. So it's within the normal rate. Rhythm regular, both atrial and ventricle. So you're counting your rhythm here. Your atrial 1, 2, P waves 3, 4, 5. Is it 1, 2, 3, 4, 5, 6, 7, 8? And then that just sort of carried over before that. That's okay. It's still okay there. And so that's regular. And then ventricular is your QRS 1, 2, 3, 4, 5, 6, 7, 8. So they're both regular. 1 P wave for each QRS. Yes, we see that there's 1 P wave for each QRS. And 1 QRS for each P wave. That would be something we look at too. They should be always upright and consistent. PR interval should be normal between 0.12 and 0.20. And I believe if we count those out, that would be all within, those intervals are all within normal limits. And the QRS is consistent with shape and duration. In other words, there's not a widening here. They're all pretty much consistent. And that is the end of the 5-step approach to reading